first simple program on this two-dimensional array. What we'll do is, we'll read a matrix of order m by n and we'll try to find the sum of all the elements of the matrix. So, how do I go about the entire process of two-dimensional array programming? Always remember, there are three things which you're supposed to do in a two-dimensional array program. First is to read the order. So, I had to read order of the matrix. Now, when I say order, I have to read rows into a variable say m and columns in a variable called as say n. So the first thing which I'm supposed to do is I'm supposed to read the order as m rows and n columns. Second, once the order has been read, then the second part is to read the elements. So I had to read elements. Now when I say read elements, for that I need a two-dimensional array. Let's use a two-dimensional array say A. I'll have a two-dimensional array A which will have m rows and n columns. And let's say this array has two-dimensional array A. And this array A, I'm supposed to read the elements on this particular A. So these are the two things which remain common for every two-dimensional array program. The first step is to read order m and n. Second step is to read the elements, that is A as a two-dimensional array, A of 0, 0, A of 0, 1, A of 0, 2, A of 1, 0, A of 1, 1 and so on till I reach the mth row and the nth column. So once the entire elements have been read, then the third step is to do the operations on this. The operation depends upon how the elements need to be modified. Do you wish to modify only one element of the matrix? If you are modifying only one element of the matrix, then you can refer it as say individual indexes as A of 0, 0, A of 0, 1 or A of 0, 2. But if the entire matrix elements need to be operated, if the entire set of matrix need to be operated, then what I need to do is I need to again use a nested for loop. Again in that, if you want to do only some specific condition, specific numbers to be changed, in that case I can even use a condition. So to refer to the index, I'll use I and j. So if I just say I and j, the values of I and j, they indicate only rows and columns, whereas A of I, j indicates the element at that particular row and column. Suppose if I is 0 and j is say 2. So A of 0, 2 is the element. So when I'm referring to the element, I should always say A. And when I'm referring only the columns and only the rows, in that case I and j. So now my task is to read these elements and then find the sum of these elements. Now let's look at the program which is supposed to be done for this particular task. So the program will consume a two-dimensional array. I'll have this particular program for you. So I'll have a program which contains a two-dimensional array A of 10, 10. Now when I'll declare maximum size as 10 rows and 10 columns, which means that I'm putting a limitation on this particular two-dimensional array. The program will consume maximum 10 rows or will have maximum 10 columns, not more than that. This means that this is a static memory location. What if I declare A of 10, 10 and do operations of just say 3 rows and 3 columns? Will these remaining rows be allocated to someone? No. The remaining rows will not be allocated to someone because this array is static. We can't compress, we can't neither expand this particular array. So the maximum size is 10 rows and 10 columns in this. So I'll have this particular array as 10 rows and 10 columns. I and j are the loop variables which are going to be referred for rows and columns. M and n indicates the maximum rows and columns which the user will enter, and S is 0. As I said, there will be 3 tasks which will be done. First task is to read the order. So I'll read the order of the elements. I've said in a comment. You can even use comments or you can directly start with the next instruction. Printf, enter the order of the matrix. In response to this question, the user will enter some rows and some columns. Let me say m is entered as 3 and n is entered as 3. So this is m and this is n. Now I have to read the elements of the matrix. So I'll have a for loop I equals 0, I less than equal to n minus 1, I plus plus, j equals 0, j less than equal to n minus 1, j plus plus. And with this j, I'll have a scanf. You can put or wrap this particular scanf under a pair of curly brackets. If not, still scanf is considered as only one instruction. If you remember, in the for loop or the nested loops video, I have said that if a loop contains only one instruction, the curly brackets are optional. So when a for contains only a scanf, the curly brackets are optional. So now substitute the values of A of ij. So I0, J0, 0, 0. So here I have a two-dimensional array which has got 10 rows and 10 columns, of which I'm going to use only 3 rows and 3 columns. So let me put 3 rows and 3 columns, a two-dimensional array. This is my array A, and in this I'll read elements. Let me enter some elements for your sake. So I'll say 4, 7, 2, 5, 6, 1, 8, 3, 9. Assume that the user has entered these values. So once the user enters these values, so I am at this particular place. We have read the order, we have read all the elements of the matrix in this particular curly brackets. Now, once the elements have been read, my task is to add up all these elements. How to add these elements? For that, what I'll do is, I'll say, take a variable s as 0, and add this particular s with every element of the array. How do I refer to the first element of the array? The first element of the array is referred as A of 0, 0. Second element is referred as A of 0, 1. Third element is referred as A of 0, 2. Fourth element as A of 1, 0. Fifth element as A of 1, 1. Sixth element as A of 1, 2. Then 2, 0, 2, 1, 2, 2. We know that a pair of nested loops will make me to move around these particular locations. If it can make me to move around these locations, why don't we add A of 0, 0 with S? So A of 0, 0 when added with S will become 4. So initially S was 0, 0 plus 4 is 4. Go back, increase the value of J, again add S with A of 0, 1. 4 plus 7 is 11. So 0 was modified to 4 and 4 is modified to 11. 11 plus the next element, that is 13. Again 13 plus 5 is 18. So every time we keep on changing. 18 plus 6 is 24. 24 plus 1 is 25. 25 plus 8 is 33. 33 plus 3 is 36. So the elements have been kept on overriding. 36 plus the last element 9 is 45. When you go back, I crosses this number of rows. So it means that S value is 45. This indicates the sum of all the elements of the matrix. So what we did was, we read the elements, we kept on adding every element with the array element. That is S equals to S plus A of ij. Initializing S equals 0 is compulsory. If not, it will take a garbage value and then add the first element to the garbage value. Here, I am supposed to add 0 with the first element so that there will not be any difference in the sum. So S equal to S plus A of ij. All the elements have been read. And finally, what I'll do is I'll display sum of matrix elements equals to percentage d comma s. So here we have displayed the sum of all the elements of the matrix. Very first program, observe the flow or the block of the program. First part, read order. Second part, read elements, and then processing part. If you feel that the program need to be compressed, you can compress, you can add processing part in the reading part itself. Preferably avoid doing that. If you observe, the entire process is simple, plain, nested loops itself. There's nothing more than that. Hope you have understood this particular program with an example. Take your own numbers, increase the number of rows and columns, put your numbers, and then again work with these sum values. So definitely you'll be able to understand the entire concepts thoroughly. Thank you.